Example 2, we're going to find the slope of the tangent lines to the graph f of x equals x squared plus 1 at the points 1, 0 and negative 1, 2 as shown at the figure. So if we look here, we have our function graphed in black, f of x equals x squared plus 1, and I want you to find the slope at the point 1, 0. So you can see that the tangent line here, okay, it looks like the slope of that line, if I was to guess, would be 0. And we're going to validate that, check that using calculus. They also want you to find the slope of the tangent line when x is negative 1. So the slope of this line looks like, if I go from this point to that point, up 1, up 2, 1 to the left, it looks like that would be negative 2. So let's see if that's correct. Okay, so we're going to figure this out by using the slope of the tangent line here, which is also known as a derivative. Okay, so we're going to find, I'm going to call this f prime of x. That means the derivative of the function, and we're going to use the limit of f of x plus delta x minus f of x all over delta x as delta x goes to 0, approaches 0. Okay, we're going to figure out what that is equal to. Remember, this right here, this function right here, that is the slope of the secant line. And when you force delta x to approach 0, then this whole thing will equal the slope of the tangent line. Okay? So, for this particular problem, we know what f of x is equal to. Okay? Let's find f of x plus delta x. So I would need to do this. I would need to plug in x plus delta x into x squared plus 1. So it would look like this. Then I would simplify this. So I would multiply here. The binomials, x times x would be x squared. X times delta x would be x delta x. Delta x times x would be x delta x. And delta x times delta x would be delta x squared plus 1. Then I can simplify this a little bit. I can make this f of x plus delta x is equal to x squared plus 2x delta x, these are like terms here, plus delta x squared plus 1. So now I have f of x plus delta x, I have f of x. Now what I want to do, I want to plug all of this information into this. So let's do that. Do that in blue, just give us a different color. So f prime of x is equal to the limit of f of x plus delta x, that is this guy. We'll substitute that in here. So it's going to be x squared plus 2x delta x plus delta x squared plus 1 minus f of x. So f of x is x squared plus 1. Notice that I put that in parentheses so I will distribute the negative all the way through the function. And that is all over delta x. again as delta x approaches 0. Now, I want to solve this limit. This is why we've worked so hard on limits, so we can solve this. So the limit, now we're going to have x squared minus x squared. So that's going to be 0. Also, notice I have a positive 1 minus 1, so those are going to cancel out. So now I'm left with 2x delta x plus delta x squared all over delta x as delta x goes to 0. And then the only thing else that I can do here, I can take the limit. Notice that I have this delta x here, delta x here, and delta x here. I can divide all of those by delta x. So that's going to give me 2x plus delta x as delta x goes to 0. Now I can evaluate the limit. As delta x goes to 0 here, you're just going to be left with 2x. So f prime of x, which is the slope of the tangent line, is equal to 2x. Now the only other things that they want us to do here, they want us to figure out the slope of the tangent line at the point 0, 1. So this is x, this is 1, so let's do that first. So the slope of the tangent line of f prime when x is 1 would be equal to 2 times 1, which would be 2. I messed up somewhere. That should not be. Excuse me, I messed this up. This should be the slope of the tangent line, which is equal to f prime. X is 0 here. So this would be 2 times 0, which would be equal to 0. So that makes sense right here. The slope of this line here is 0. This is using the calculus to show that. Also, I want to figure out the slope of this tangent line when x is negative 1. So I'll do the slope of the tangent line, which is f prime of negative 1, which would be equal to 2 times negative 1, which is negative 2. So that would be the answer for this question. So quickly to recap, the definition of the derivative of a function, okay, is this. So this f prime of x is equal to the limit of f of x plus delta x minus f of x all over delta x as delta x goes to 0. Okay. Again, this is also known as the slope of the tangent line, but probably going forward we'll call it a derivative. Okay. Some other notation for the derivative that we'll use throughout this class will be f prime of x, which means the derivative. These are all notations for derivatives. This is the derivative of the function y with respect to x. I'll write this out because it's good to be able to say this. It's going to make more sense as we continue to work with derivatives. The derivative of y with respect to x. This is just the derivative of y. This is just saying the derivative of f of x with respect to x, so it's similar to that one. And this one, we won't use this one in this class, so we won't worry about that. Okay, so here is some more notation. dy dx is read as the derivative of y with respect to x, so I wrote that out, or simply dy dx. Okay, so the derivative of y with respect to x is equal to the limit of delta y over delta x. Delta y is just y1 minus y2, or y2 minus y1. Delta x is x1 minus x2, or x2 minus x1. So you can see here, this is just the slope formula here. And then here, this is just the slope of the secant line, which again is another way to write the slope formula. When you take the limit of the secant line as delta x goes to 0, you're going to get the derivative.